Yeah, so we were talking about graph theory. In graph theory, we have studied cut set and loop set things. Yeah. So we studied about cut set and loop set. This is also known as tie set. This is associated with KCL. This is associated with KVL. Before these two, we also studied something called incidence matrix, which is known as matrix A. In cut set, whatever we are writing, that matrix is known as Q. In loop set, whatever we are writing, that is known as B. When we are writing cut set matrix Q, we are doing following things. We draw the graph, which is oriented graph, right? When we are drawing this and we are applying Q, we are going to make tree. Tree is the one which will have one twig and sorry. So through tree we are defining twigs. All the edges associated with trees are known as twigs. Then when you are cutting the combination of twigs and other cords, we make sure that there will be only one twig and more number of cords, right? The direction wise, the direction will be same as of twig. When we are numbering, all twigs will be 1 2 3, others will be 4 5 6 or whatever. And when we are cutting it, we make sure that there will be two partitions, right? And those are independent. When we are writing B matrix, we of course draw graph which has to be oriented. When we are saying oriented, it has to has some direction. We make tree which will have all the twigs, others will be cords. When we make the loop, we make sure that there will be one cord and more number of twigs, and direction of loop set will be of cord, right? This was the summary what we have studied, right? So is there any doubt in writing this? So today more number of people are there, so exodia is over or okay, starting. Okay, so the topic which has left was state variable formulation method. So it's very simple thing, it's not so much complicated, but you should know these things very well. If you know these things, then it's easy to write state variable formulation also. So what state variable formulation says, those who are studying basically control theory, they will also see such kind of matrix. You studied this, you're done, you're, you're done this one. Okay, how many are studying control theory? 10 students are studying, that is what I know. Right. Okay, so generally so do you know name of this equation? Is there any special? What is x? What is x dot? Mm-hmm. So this is state variable method where x dot is a derivative of x, variable x, right? X is input. Oh, x is state variable. U is input, right? So this is same thing, but replacing x dot. So generally this equation is followed in all control theory equations when you are defining one variable, which variable is known as x, and that is associated with its derivative by ax plus bu, right, where u is input. So if there is a system which has input, output, and when you are writing the equation, it's x dot equal to ax plus bu. If you are writing x dot in Laplace, it becomes Laplace operator times x. So this is same thing, and I'm writing ax plus bu. So this is A matrix, this is B matrix, and this is, instead of u, this book is following w, right? Right. So it's equal to Sx equal to Ax plus Bw. This is similar to what people are following in control theory, or all the theories which you are going to study, right? Have you studied that state variable graphs? Right. This is in control. Those who are not studying control, don't worry. Okay, it's not prerequisite. Okay, so this will be the equation which is governing all the systems, and output is defined as Cx plus dw. So there will be one matrix C, D matrix, A matrix, B matrix, right? So there is one more theory, but I am going to teach that maybe after teaching two-port network. This is called observability controllability. Whether your system is, so there are two things are there. So some systems which you can just control, just you can observe, you cannot control them, right? And one system is that you can observe it, you can control it both. So generally this is known as controllable system. One system is known as observable. This is decided by these matrix. So C D matrix will tell you whether system is observable, controllable, and same thing can be applicable to anything which is not just mechanical thing. It might be electronics also, or it might be some other system. Even chemical process control is also there, where people are using such system, and they are controlling or observing, and through that they can write down the mathematical equations, and through that they can uh, actually control or observe. So in state variable formulation, we understand what is independent voltage sources. All the function generator, uh, power supplies, all other things are actually independent voltage sources. They have to be on tree. We know what is tree, right? And all the people might take different trees, so the solution may be different. The answer will be same, the final answer will be same, but the procedure wise you may have different tree. So we need to look at that. Capacitors has to be on tree, resistors, inductors has to be on tree. So as many number of resistors, capacitors, inductors, or voltage sources you can keep it on tree, that's the best thing. And thereafter number the capacitors on core tree. We know what is core tree, all the chords are actually core trees, right? So similar like the procedure which has been given by this book may be like boring, but when we are doing this it will be easier by looking at this network. So this is the problem number 3.9.1 which has been taken from the book Ziri Vlack. So what we need to do, we need to find out the state variable formulations for the network shown in the figure, and use the tree indicated in the figure by thicker lines, or others will be the lighter one. So when we are drawing the graph, you are going to have following things, right? So when you are drawing this graph, you may have different kind of things. Then you need to give the direction. This is arbitrary, by the way, right? So maybe you can choose these three as tree, right? Other edges are not possible on tree, right? So these three you can take, or others are also possible. These three you need to name them as 1 2 3. Others will go to 4 5 6 7, right? Or maybe rather than doing this, let's name this E1 and 2, because E is voltage source. It has to be on tree, that's why I have kept on. Where is that event? Yeah, so all the independent voltage sources has to be on tree. So miss somewhere. Okay, we were here. Okay, right? So that's why this voltage source is on tree. Others are co-trees or chord, right? And through this we can write down following matrix Q, but we are going to write down Q augmented, which will have E12 as three cuts, sorry, 1 2 3 cuts, and you are going to have following edges, right? So can you help me in making the cuts first? So Komal, yeah, can you help me in making the three cuts, because we need to make three cuts, right? Right, so this is cut number one. The direction will be of E. Let's call this one as C1. So let's write down the equations first. So which will be the entries here? 1 0 0 1 0 0, right? Now can you help me in next cut? hmm? 3 1 4 5. Okay, so which direction should I take? Right. Okay. hmm? Plus 1. Okay. Hey, it will be minus 1, right? Yeah. 4 is plus 1, 5 is plus 1, 6 is 0. Now let's make third cut, right? And the direction will be this side, right? Can you, third is not there, 4 is minus 1, 5 is minus 1, 6 is plus 1, right? So using this matrix, what this theory says, when you are going to write down the ultimate matrix, that matrix will have following entries. One will be current, but this is a T will be the transpose voltage, and these two are the VC and IC. When you are writing this, these two will be 0. This side minus QC, this minus QC is nothing but whatever is coming from cut set. You have to keep it that one here. And if you remember, QC is nothing but, so if you have 1 2 3 part of tree and you have three cuts, you are going to have such matrix, right? If you remember, so whatever is remaining, you are going to call that one as QC. That QC I am talking about, right? So that QC, but with all minus sign, will be here. Without minus sign, the transpose of that one will be here. That you need to write down. So here QC is this one, and minus of QC will have this one, right? That will go to the matrix which is here, and transpose of this one right. So that will go here. Then you have to feed the entries. When you are feeding the entries, so you are going to have three currents which are part of tree: IE, I1, I2. Similarly, you will have three entries of tree: VE, V1, V2. This is 0, this is minus of QC, this is plus QC of T with transpose, and this is 0. This is what I fed here, and all others are V3, V4, V5, V6, and this side I3, I4, I5, I6. When we are writing this equations, we need to make sure that what we are doing is we want to make such system which is going to have all the entries which is multiply with Laplace operator, right? This is what we are keeping in mind. This will be useful. So from here we can write down V is equal to E, VE is equal to E. Similarly, if I want to write down I1 is equal to SC1, look at this here, SC1 times V1. We are writing I1. The reason is I just want to make sure that I'm going to get all the entries which is multiplied with Laplace operator. This is what I want. If I'm writing in uh, actually instead of current, if I'm writing in voltage, it's 1 by S, right? So we are not going to take that entry, but we are going to take the entry which is going to give me just multiplication of all the Laplace operators. So in that case, this was E. One, two, three, four, five, six. So you need to write down all the equations, and on this particular age, what current or voltage is flowing, that you need to write down in uh, the formulation which we learn, where I2 will be SC2 times V2. Here it's SC2 times V2. V2 is the voltage. Because of this age, we are giving number 2. Similarly, for I3, you are going to have G3 times V3. These are the transconductances. But when we are writing I1 to I5, there is no problem. When we want to write down I6, I6 is the one where you have an inductor. So if you are writing in terms of current, then this will be 1 by S times L6, right? So we don't want this. So current will not be applicable here. We are going to write down voltage. Look at this. We have written voltage here because this is going to give me voltage. This is already voltage, right? And we are going to write down the new equation where IE is IE, because IE we have not written anywhere. It's already voltage source. If it is current source, we need to write down current. If instead of that, if there is somewhere J is given, then you can write down this. Then you can replace IE with J. You may have multiple values of IE1, IE2, IE3. that you have to incorporate it here in the augmented matrix. So IE is IE. I1 we have already found out, SC1 V1. I2 is SC2 V2. V3 is V3 V4 V5 V6 we already found out, but V6 is SL6 V6. Similar to that, we can have V is E, V1 V2 are already given. The current will be replaced and 6 will be here, right? So from here you can write down IE in terms of E, V1 V2 or something. So IE is equal to nothing but minus G3 V3. Can you see this? IE is equal to minus G3 V3. Fourth entry we need to see, right? Similarly, SC1 V1 is equal to G3 V3 minus G4 V4 minus SC5 V5, right? So you can write down these equations. If you can write down these equations, we can write down this V1 V2 V6 because these three are the one which are coming exactly on tree. Sorry, V1 V2 V1 V2 V6. One second. Okay, V1 V2 V6 is the one where you need to uh, take all the trees without voltage sources, and the one which we have replaced with actually the current, that is what needs to be taken. This is what we are doing, and when you just modified the equations, you will get this thing from here. So which is exactly as right. So this was just about the state space formulation, but I am going to revisit this afterwards. There will be one chapter which is not given in your syllabus, but uh, it will be helpful for you to understand other things. So we will revisit this where we have to understand observability and controllability. So let's start the new topic, which is two port network, because without understanding this it's difficult to understand other things. Okay, so that's a new topic, completing graph theory. Graph theory is cut set, tie set, right? These are the two main thing, cut set and tie set, or loop set, right? So mostly all the competitive exam people are asking these two metrics to be written. So those things I kept it in our assignment also. You need to write down three matrix Q, A, B, or maybe sometimes augmented uh, cut set matrix or augmented loop set matrix BA, right? This was already given in your assignment. Now for the new topic, I am returning back to our main book, which is Franklin Kuo, right? Most of the uh, most of the things are copied from just Franklin Kuo, chapter number 9, network analysis, part 2. But sometimes I am going to refer this book also, which is Deezer and Kuo. You can use this book also, where the chapter number 17 is useful, two ports, right? This book is almost talking about all the passive elements, but what I want to cover here is little bit of active elements which can be modeled as two port network. So that is what we are going to study from this book. So transistor basically, right? So in two port networks you can have following parameters. One is called impedance parameter or Z parameter, admittance parameter means Y parameter, ABCD, T and hybrid. So these are the different way of writing the equations. We already looked at admittance matrix, if you remember, using a transistor or by calling it VCT. We already studied that, but we have not studied the two-port network, the really what is two-port network is. But we just replaced transistor in passive components and we found out Y parameter. Similarly, we also found out Z parameter, but other than that, there are different parameters which are known as ABCD, T, and hybrid, or this is also known as H parameter, small h. Have you ever seen H parameter? Okay. So these are the topics. So I'm going to follow from 253 to 279 pages without missing anything, right? So whatever I'm speaking, it's like, if you want to see the notes, it's book, please follow the book, which will have everything. Sometimes I'm going to follow something from here. If you think that you are expert of these topics, then you can go to other book which is going to talk about two port network, right? Okay, this chapter is very easy actually. So what is one port network? One port network is the one where if input is V, there is a current which is coming back, and the entire network is defined by only one equation, or maybe, right, or maybe, or something like this. So there will be only one equations, right? Fundamentally you will have only one equation, then that port will be known as one port network. So let's assume that. So do not make such mistake which Franklin Kuo made. It has to be in capital, okay, because these two are the gentlemen who invented these units, right? So if V is equal to 10 volt and I is equal to 2 ampere, then we know that the input, or okay, one more word I wanted to teach you, which is known as driving point impedance or driving point function. So either you have one port network or two port network or multi port network. In all the cases, if this particular port can be written by some equation which may be z in terms of z or in terms of y, both the functions are known as driving point function. If it is written in impedance, it's known as driving point impedance, because most of the people are interested in what is happening to the impedance. If you remember, I told you, if you want to connect two circuits, two one port networks are available. If I am connecting this point to this point, if the input impedance of this one is low, then maybe this voltage node cannot drive it, and you have lower voltage than what you are expecting. This is also known as loading effect, right? So the driving point impedance is the most important, because this node is going to drive the next node. So this is the driving point port also, which is going to drive the previous impedance, or this point will drive the next impedance. That's why this is known as driving point impedance or driving point function. If you're writing just mathematically, and if you solve all these equations, people are calling it driving point function. All the control theory guys, they are calling this one as driving point function without telling that this is circuit, or because that is a more generalized function. When you are into circuit and you are writing in terms of impedance, we don't call it driving point function, but we are going to call it driving point impedance, right? So here driving point impedance, if I want to find out, that is going to equal to V by I, which is equal to 5 ohm, which is actually going to be difficult to drive by other system, because if you know, I know that if I am going to design a system, I'll make sure that the output impedance will be something around 50 ohm. But if I am going to connect it to one port system which is going to have the impedance of 5 ohm, when I am going to connect it through a link, through a probe, something, it will not able to drive it, because this is a low impedance. Low impedance cannot be driven, right? Okay. There is one more example where we can see one port admittance, where whether the one port is actually a single 5 ohm resistor, two 2.5 resistors in series, or two 10 ohm resistors in parallel, all are equivalent when we are actually deriving the impedance, right? So if it is 2.5 and 2.5, if I am looking at the equivalent impedance, it will be 5 ohm. If two 10 ohm resistors are in parallel, it's 5 ohm. So all the way, like, all the driving point impedances are same for me, and that is what my previous circuit will look into this system, and that is going to cause the problem, or it will help my circuit to drive. So all are equivalent, and that is not much importance, as long as we assume that there is always 5 ohm, because sometimes it happens that when you are keeping two resistors in series or in parallel, because of some variation of value of the resistance, you might have different value. Do you know this, right? It's 5 ohm plus or minus some percentage, if you know this, right? So as long as this percentage and everything is same, if it is 5 ohm, I'm happy, right? All things are same, but our primary concern is to find out the current and voltage relation, and which one you are taking as output, which one you are taking as input. That will decide whether you want to take admittance or impedance or abcd or hybrid, right? So let's assume that the current is equal to 2s plus 3 and v is equal to 1. Then input impedance is equal to I by v, which is equal to 2s plus 3. By looking at this, can you draw the circuit? Can we draw the circuit if the input admittance is equal to 2s plus 3? Let's assume that there is a plus sign. So what is the meaning of plus sign in admittance? Parallel, or somebody told the correct answer? Okay, parallel. So Shashi says parallel. So there are two elements which are going to be in parallel. If I am going to look from here in terms of input impedance, input admittance, sorry. So what will be this value and what will be this value? Hmm? Sorry, register, yeah. No, no, it cannot be 3. Look, the unit of this one is mho. It's not ohm. It has to be 1 by 3. What about this one? 2s or 1 by 2s? You should not forget this. Laplace operator plays the role here. So now can you replace these two elements with the real element known to you? I can help you in keeping this. What about other one? Capacitor. Right. Right. So your answer was correct, right? But similar to this, if I want to find out if input impedance is equal to 2s plus 3, can we draw the circuit in the notebook? So it will be in series, or look, this is impedance. It has to be in series. This is 1 by 3 or 3, right? And what about this one? Okay, right? Wrong or yes? If it is 1 by that, this is 2s Laplace operator. How we are keeping this? Inductor or capacitor? Inductor is correct answer or wrong answer? Right? So 2s plus 3. Okay. So let's this was just a glimpse of our next part of our course, which is known as synthesis. So you will have much more complicated equation than this one, and you have to find out the circuit. Right now the first part is analysis. Let's be expert of analysis, and thereafter we'll go to synthesis. So in analysis, this is the last chapter. In analysis, this is the last chapter. After learning this, we'll go to the synthesis, where the the functions will be given. Driving point functions are available, and you have to find out the circuit, which will be RLC only, right? So this course is limited to passive circuit, so we are not moving to transistor. However, you can synthesize the transistor also, right? So if you have a network which is going to have two pairs of voltage and current relationship, instead of one relationship, if you have two relationship, then that particular network is known as two port network, right? Where you can see that there are two ports are available, one is V1 and one is V2, and there are two currents which are flowing into the two port network which has I1 and I2. So you may have four variables I1, I2, V1, V2, and you can write down two equations which are interlinked to each other. Two of these variables are dependent and two of these are independent, right? So let's say that V1 is depending on I1 and V2 is depending on I2, because it's depending on whether it's Z, Y, ABCD, H parameter, or T parameter. Any of the parameter can be written in terms of two port network. Multiply by current or voltage will give you the relationship. If it is impedance function where it is written in terms of Z, then V can be written in terms of Z and I1 and I2, right? So V1 and V2 are dependent here, and I1 and I2 are independent. Other way around also you can say, but if I want to write down in terms of impedance, then that will be the case. Okay, so let's move to the topic where we need to write down the Z parameter. So Z parameter is nothing but impedance parameter. Most important part of this course is also we should understand that these parameters Z, Y, others parameter, and one more will be derived from here, which is known as S parameter. Those who wants to pursue communication engineering as their future, then they should be expert of this one, right? So right now we are not going to study S parameter, but if you are studying communication engineering somewhere, somebody is taking communication engineering this time, okay, so then you are going to study only S parameter, but it will be derived from here only. It will be similar to what we are studying Z, Y, ABCD, H. Okay, so Z parameter, I am going to write down two equations. One is V1, one is V2. V1 is equal to Z11 times I1 plus Z12 times I2. And V2 is equal to Z21 times I1, Z22 times I2. Right? Is it difficult in understanding? Okay. If you agree with this one, and we also agree that V1 and V2 are dependent, I1 and I2 are independent, then we can define four quantities which are not known to me right now, which is called Z11, Z12, Z21 and Z22. Those quantities I can write down. If I am interested in writing down Z11, then it's del V1 by del I1 when I2 is equal to 0. And this is not there, I can write down this. Similarly, I can write down Z12, Z21 and Z22. If I want to write down Z12, that is going to give me del V1 by del V2 when I1 is equal to 0. And similarly, yeah, I1 equal to 0. Right? Similarly, you can write down other four entries. Right? So it is written here V1 by I1, but in practical way, that is del V1 by del I1. So it's a derivative you need to find out. Okay. Now there is one more more thing we need to understand. If I want to find out the this port, I want to assume that there is only one port and other port will be 0. This is what we are doing right now. If I2 is 0, if I want to find out Z11, at that time only one value will be active, V1 or V2. Both the sources are not active at the time. Okay, where is it? Yeah. So when we want to find out, let's say Z12, at that time it's V1 by I2, where I1 equal to 0. At that time V2 is not playing any role. So you need to make sure that I2 is also 0 and V2 is not there. If I want to do that, that particular analysis is known as open circuited analysis, where we are not considering the other node. And what is exactly happening when we are saying I2 is equal to 0 means this is acting as an open circuit and there is no current flowing inside. That is how this name open circuit came into picture, right? So such circuit is known as open circuited circuit, and this analysis is known as open circuited analysis. One more thing, Z11, look at these numbers. 1 1 is between 1 and 1 prime port. 1 prime might be ground or might not be ground. 1 2 is between it has to be 2 2 2 is between 2 and 2 prime port. Both the Z11 and Z22, if you want to find out, it has to make sure that one of the voltage source is not available and the other current is 0. To make the other current as 0, you need to make that particular impedance open. So in that case, this kind of impedances are known as open circuit transfer impedances, right? Because Z11 is nothing but V1 by I1, Z22 is equal to V2 by I2. Generally, it's to solve the complicated equation, we have to take derivative, right? So these are open circuit transfer impedances. However, if you are looking at Z12 and Z21, they are related with voltage to current at the other ports. So what exactly it means, if I want to find out Z12 or Z21, if I want to find out Z12 is equal to V1 by I2, so V1 depending on this current, or if I want to find out Z21, V2 depending on this current I1. So that is what I am writing here. Z12 and Z21 relate voltage to current at other ports, right? And these two impedances are known as open circuit driving point impedances, right? But there is one adjective is already given, it's open circuit driving point impedances, right? So if we are using such words, please do not get confused, and whenever you think that you could not understand any word, please interrupt me, because these are new words, right? You already knew these words or no? Okay. Okay, so we'll find out Z11 and Z22, which will be easier. So what will be the Z11 when there is V1 and I1? At this port, I want to find out. So at that time, this is open circuited. There is no impact because of V2 and I2. So what are you seeing? ZA plus ZB. Similar to this one, ZB plus ZC, right? By the way, we already learn one thing. If you have such network, if you cascade such networks, these are known as pi networks. right? However, if you have such network, do you know the name of this network? Like pi network? What is it? T network? Okay, it's very easy. So right now what we are doing is with the modeling the T network. Same thing can be done by pi network also. Okay, maybe rest of the thing we'll talk about maybe from Thursday. And assignment number two's exam is on Tuesday, April 2, same place, same time, right? Please do not be late. There are around more questions are given, 20-25 questions are given, copied from two books, Kuo and Ziri Black. It's copied from same books. Their solutions are also available online. Okay, so you people are intelligent enough to find out.